we're talking through, yeah.
So I'm going to measure the present floor width. So pull it tight again. Right, present floor width, you need to write it down on your recording sheet, is 11 metres 53 centimetres. So 11.53 is present floor width. 11.53, so 11 metres 53 centimetres. One sec. I'm now going to wind up the tape measure because I don't need it anymore. Ready? Okay, so just keep recording, I have to stop it. Okay, so the next thing we're going to do is we've got 11.53. If you look at your worksheet, it tells us our sampling interval. Can anyone tell me how we work that out then?
Divided by 10.
Right, so 11.53 divided by 10 gives us what?
1.153.
Right, 1.15. We're not going to go to 3 decimal places. So 1.15. Could you write that down somewhere? It gives you the calculation. It says 11.53 divided by 10 equals 1.15. Okay, so once we've done that, we've now got the interval of measurement along the transect. Why do we not want to do the following? What's wrong with this? This is what we could have done. We could have gone, right, we need 9 depth measurements. That'll be all right, that one. This one looks quite deep. That'll be a good one there. Oh, this one, look at that, classic, brilliant depth. What's wrong with that?
Bias.
Right, it's not even. I've introduced bias. Maybe I don't want to get my hands too wet, or maybe I don't want to bend down so much, or maybe I just don't like the look of that dark patch. So I've introduced bias. The sampling strategy by dividing it by 10 is a systematic. Don't know your name, just listen in please. Girl with the grey hoodie, blonde hair. Just tune in. Yeah, fantastic. So by dividing by 10 you've created a systematic sample. Every 115 centimetres, 1.15, we are going to measure depth. I've reduced bias because I had no way of saying, oh, I don't like that bit, that's where I'm going to do it. I'm going to need that, sorry sir. To help us do that, I've got the metre rule and I've got some £1 special, £1 lamb pegs. And what I'd have done is the following, which you would have done. I'd have gone to where the river touches the bank. I'd have measured 115, so this is a metre rule plus another 15. So I'd have gone that's 1 metre. £1.15. Now for those people who can't see, I'll just randomly put a peg. So I've done 1.15 there, I'll do another £1.15. So what I've done is, I'm dividing the transect into 9 equally spaced points using my peg as a marker for where I'm going to do the next bit. Mr. Schofield's going to talk us what we then would have done. So on your worksheet, where it says intervals, yeah, and you've got number 1, can you write in 1.15 m? At interval 2, can you write 2 metres 30? At interval 3, 3 metres 45.45, etc, etc. I don't want you to do all the maths now, it's just an example as we demonstrate it. Okay, so Mr. Schofield's up next.
Right everyone, so we need to measure the depth at each of these intervals using our meter ruler. Miss Martin spoke to you this morning about some potential errors that are quite easy to make. So I'm going to demonstrate the errors first and then I'm going to show you how to do it properly. So potential errors when taking a depth measurement. For the purposes of the people stood at the back, I'm going to do a depth measurement here in the middle so you can see. Right. Error number one. You take your ruler and you place it into the river and your ruler, due to the flow, starts to bend. That's going to give you an inaccurate reading. For those of you stood in the river, what's happening to the water against my ruler? It's pushing upwards because the flow of the water is hitting the ruler and rising up. That reading would be wrong. If that's wrong, all the other calculations you do will be wrong. How could we rectify that problem? What could I do with my ruler instead? Put it sideways so less of the water's hitting it. So I put it sideways and then I need to take a reading. Error number two. People can't be bothered to get down to eye level to take a reading, so they just say, oh yeah, that's 20 centimetres. When in actual fact it might be slightly different. One other thing that you won't realise, when human beings take readings like that, we misread things, not on purpose, we automatically do it. It's called parallax error. We either over or underestimate things. So you have to get as far down to eye level as you can so you can take an accurate reading. So you need to get as far down as you can to take that reading. So in order to rectify the problems, you turn your ruler side on, you get down to water level as best you can, and you take a reading. One other potential error that lots of people make. They put the ruler in, as I've just said, and they stand here and take a reading. What's the problem with me standing here? What am I doing? I'm blocking the flow of the water. The reading that I take for depth won't be correct. There's no way it will be correct because I have diverted the water away just by being stood here. So instead of standing what we call upstream, you have to stand downstream of where you're taking the readings. You put your ruler in, side on, you get down to water level and you take an accurate reading, as accurate as you possibly can do. These rulers have graduation, so you should be able to say, oh, that's 26.7 centimetres, for example. The more accurate you can be, the better your results are. We need the depth measurements as well as the width measurements to work out the cross-sectional area, and then we can determine what the difference is between here and upstream at Lancet. Does that make sense? Excellent. I think that's it.